Energy Transition Professions in Demand. This is Cleveland Jones. Let's see who is Cleveland Jones, a famous professor that's working in Brazil at this time. He is a consultant in the oil and gas industry, researcher at ENOG, and a member of the Geoscience Advisory Board of NXT of Canada. And what else I could say about? He can say something. Please tell us, Professor Cleveland, a little bit more about your career and your professional skills.
Yes, it's interesting since we're going to talk about careers. Obviously, here, but currently, I'm very focused on technology. Not necessarily the only technology that I'm working on, which is geophysical and new energies, but technology in general, because that's where the solutions for the world will come, and we have to focus on those.
Perfect, perfect. And I asked about Professor Clement to say something about him, because today we are talking exactly about professions, opportunities in the energy sector. So with the energy diversification that is bringing new opportunity for professionals, engineers, physicists, geologists, and much, much more. So the idea for today's podcast to discuss the most likely professions in the energy transition sector. So, Professor Cleveland, let's start with some remarks we made here. For renewable energy engineers, how do you see the opportunities for this group of people?
Yeah, when we talk energy transition, obviously, first thing comes to mind is renewable energy, alternative energy. Very important to recognize the changes, because change is a constant, but we have to be on the crest of the wave, not behind it. So renewables, yes, they're coming. As you pointed out in these topics, yes, the engineers will be in demand for renewable energies involving wind, solar, which already have traction, but hydroelectric power. It's not so conventional anymore. There's a lot of changes happening in hydroelectric power projects, all from pumped storage, joint generation and pumped storage projects, less projects devoted to large reservoirs, and more projects devoted to less impacting systems that don't inundate such large areas. Those are important changes that careers will naturally evolve to follow and lead. So renewable energy is obviously a topic, because decarbonization and so on focuses on renewable energy, but the scope there is tremendous. If someone wants more detail, they can go to some of our other programs where we discuss renewables.
Yeah, Cleveland, please. In Brazil, for instance, we do not have probably design, develop, and maintain maintenance of. No, maintenance we have, of course, in Brazil, but we do not manufacture solar panels. We do not manufacture equipment for wind.
Exactly, Kavaya. We don't, but maybe we might, and that's where opportunities arise, because there's a lot of new developments happening, even in the USA, which always was relying on China, for example, like the rest of the world. And there are projects already in place, manufacturing in the US. The same can be said for large countries, Brazil in particular, and other countries like that. Smaller countries would have more trouble justifying turning domestic industries to produce wind packages and solar packages.
But the question is, what a young engineer can do to, let's say, to enter in the sector of renewable
Well, the first thing is to study about that. And all of the universities have engineering programs that offer various courses, and physics and mathematics applies to all of them. And if individual professionals or students, if they're young, can research that, because technology is evolving faster than the curriculum of any university. So a student, and I discuss this with my mentees, you have to research changes in technologies in renewable design, manufacturing. It's what's happening at the crest of the wave that's important, because you can be trained as a mechanical engineer and then apply basic knowledge to, for example, wind development, and companies that are ready to start manufacturing, not just installation, goes beyond that, can use that skill.
Perfect. And my question for you, please, Professor Cleveland, the university in Brazil, I mean, are they prepared to give these people, these students, enough capability to be part of this market? But before you come with your sides, let me show that Jorge Oliveira is in Lisbon.
Good.
Is giving us good evening,
From Lisbon.
Jorge. And Anderson Pedroso from PUC Rio.
Good.
Thank you, Anderson.
Welcome.
Welcome. So that's the question. The university in Brazil are prepared. What are the groups of university in Brazil that are making these people, let's see, qualified?
Good question.
This problem?
No, and they aren't prepared to do that anywhere. Not in the U.S., maybe in China. But, that's not the purpose of the university. Maybe technical schools, you could argue, they could provide some technicians that are going to do specific, but the universities are there to provide students with the foundational principles of physics and general disciplines that energy requires. Then, as the business model develops, if we're talking about wind energy, as the scale increases and companies decide to bring manufacturing, it doesn't have to be all at once. First, they can start bringing the blades, then this, then the other.
It's okay. Yeah, but okay. But what's the difference between, let's say, China and Brazil, or China and the US? Because they are manufacturing and selling and exporting from there, and we do not.
China is a completely different model. That's something apart. They are basically a country that's acting as a technical school with a direction, and it doesn't provide a choice. It provides a mandate. We're not ready for that model. Not in Brazil, not in the US, probably in very few countries. So we have to use the model, the educational and economic model that we have in these countries, say the Western world, and adapt it. And it works very well without being a Chinese model.
But they are more practical. They are more focused, target in the solutions and selling processes that we do not know exactly how do we sell things to, how do we export.
But is practicality all of it? No. For example, the United States is still a very strong leader in new patents and so on, not having the model that China has, but having a strong foundational university education system that provides a very strong foundation of basic scientific and technical education. Then in the universities, the students and professors will develop projects that eventually will lead to innovations and eventually lead to entrepreneurial initiatives that will become companies, and they will grow and so on.
Yeah. Do we have in Brazil enough partnerships? I mean, combination between university and industry, enough kind of merge?
That's a model that is strong in the U.S. It is not strong in Brazil. It's not strong in almost any country that I know of in Latin America or most other places in the world. It is a model that is strong in Germany, for example. They have that praxis type model. A student comes in, and from day one, his entire academic career is devoted alongside basic learning to working on a project that is of interest, say, to a particular company. When he leaves, he's ready to take a job there or do something similar. That's two separate cases.
Yeah. We received it from Luis Carvalho. We need to develop blades of recycling and reuse.
Exactly. Necessity is the mother of invention. The demand
Yeah,
is what makes the new careers of interest and of value. And in a lot of cases, those new careers, like I said, they begin with
yeah,
basic knowledge, but they become real, concrete when a student, a professional comes into a company and he is retrained, reoriented with that basic information to use it to develop, the components, the efficiency or whatever. For example, the wind and the solar energy markets are perfect examples. They have been growing from just importing everything to more and more installation that is more fundamental installation, and then designing packages for parts of the installation,
yeah,
and then finally producing parts of the packages.
yeah. Going forward in this
Yeah,
list of things, energy storage specialist, is it anything special in this
yeah.
area?
I,
You think?
I, I want to say this is, in my opinion, this is probably one of the most important developments in new careers, because when we used to talk about energy storage, people would talk about batteries for appliances, for cars, and so on. Forget that. Nowadays, energy storage is a large part of the energy grid, of the economy, of any functioning alternative energy system, and certainly of the energy transition. We're talking storage systems, not battery size, but
Yeah.
institutional size, industrial size, even economy size. Pumped storage, now we're talking megawatts. Compressed air underground, we're talking about gravity storage, we're talking about
Uh-huh.
new pseudo batteries that are basically scalable to almost any size, completely different. So the principles in chemistry and so on are the same, and students should focus on that, but they on their own have to research what are new developments in energy storage, electricity,
Yeah.
mechanical, heat, and so on.
Uh, uh, Professor, sustainability consultants.
Yeah,
Everyone wants to be consultant, but it's not let's say room enough
yeah,
to do that. We need to start manufacturing, mining,
yeah.
doing the
This,
practical
this,
things
yeah, this
to
item
later
comes.
to go to the
Yeah,
consultancy
this
systems.
item has to be on the back burner of new students that are just out of the university, because it's very unlikely that they will be drawn into a consulting firm right away. But it is possible if they have, specific physics, chemistry, or whatever background. But engineers and so on become valuable as their professional career exposes them to entrepreneurial initiatives that deal with new energies, new enterprises, new factories, and so on. Those people become valuable for the consulting outfits, and they will be picked.
But not in the beginning of the career.
Less likely,
It's
yeah,
more related to the end of career because
yeah,
accumulation of knowledge
mid career.
mid career.
Obviously, at the end, very valuable. Mid career is to begin almost a new career in
Yeah,
consulting, but maybe for a large consulting outfit as opposed to being an independent
perfect.
consultant.
Perfect. Environmental scientist, not Greta's line. As I suppose
Yeah,
that's more scientific processes of environmental
exactly.
studies. How do you
Yeah,
see? And you are an
yeah.
environmentalist, no?
Yeah, this is something that, in my case, for example, environmental science was very important for me, bringing myself into the kinds of energy areas that I work with, including oil and gas. Because when you say environment, a lot of people think there is a dichotomy with environment and energy, but it's the opposite. We've come to the realization that any new initiative, if it's going to be commercial or entrepreneurial, has to be sustainable from both an environmental standpoint, and I
Uh-huh.
point out later also from a social standpoint, and it's got to make business sense. You have to make money in the enterprise is doing it. But environment is something that follows every initiative, because you have to license it, you have to
Yeah,
get a license for operation, you have to license even when you decommission it. So you can't
yeah,
run from it. You have to understand the basics, but you also have to
yeah.
understand
To
how it
start the
relates.
process.
Yeah,
Yeah, we have
absolutely.
you have a comment from Jorge from Portugal.
Yeah.
It's
But no
Pastor Plummer,
industries.
good engineering university, but no industries. Solution. Yeah, yeah.
You know, that's an
That's true.
opportunity also, George, because you can say, well, you're right. The universities produce very high level engineering students and so on. They may have difficulty entering into industrial companies that are manufacturing and so on, but they can be housed, they can be absorbed by a lot of other operating companies.
Yeah,
Concessionaires, you know, an energy concession is an enterprise that uses energy engineers. They have to understand the basics and also the new
yeah,
technologies involved in energy, whether it's electric, hydroelectric, or
yeah.
whatever.
Another comment from Luis: the intermittence of solar and wind energy needs
Yeah,
to study and create very-ship energy
that is
storage.
why the storage is an area that is absolutely as important as, you know, environmental sciences, because nothing will work without storage. If you
Perfect.
electrify the economy, we discussed this in a prior
Yeah,
program.
yeah. The other podcast, yes.
Oh,
Grid
modernization.
modernization engineers.
You put
But
that in because you know that I like that thing.
but
Exactly.
grid is more a state or a government investment. Is more related to institutions related
The
to state.
operation and the regulation maybe, but the innovation, no.
The
And
investments.
yeah, the fact is that we have throughout the world such a tremendous trillions and trillions of dollars of invested capital into energy infrastructure that is absolutely impossible to change even in 5 or 10 years very significantly. So
Yeah,
what we have to do is work with that grid that we have and try to modernize it. And sure, some are state enterprises, some are concession companies that are there for 10, 20 years. They're not that focused on innovation, but there is a great deal of
and
innovation
and,
in
and
grid modernization.
yeah, Professor. Of course, grid is a huge demand for the future because electricity is coming
Yeah.
very strong. But what are the professions that are related to this grid?
Electrical engineers, mechanical engineers, even chemical engineers, because basically you have to work electrical equipment, you have mechanical equipment that is complementary so that the grid can be modernized. And there's many examples I discussed, you know, repotentializing the cabling system. Uh,
Cable.
the chemistry is also important because a lot of times it's how you use the current grid that you have and without changing it all, but being able to upgrade it requires some of those, you know, three basics. All of those basics, mind you, we're talking about, you know, technical, scientific careers that basically, you know, obviously they require knowledge of mathematics and physics and chemistry, but specifically the grid to be modernized, it's not just the transformers, the generators, the
Yeah,
motors, the actual transmission lines. It's the ancillary equipment, and there's, you know, a whole bunch of small companies that are entering into the market with new solutions. Big companies that are sponsoring their own innovations. You know, a Siemens, for example, which is a big old company, is still very innovative, and new talent can migrate to a company like that to
yeah.
develop, for example, their new solutions for upgrading grids. So just because a company is very established and so on doesn't mean that they can't bring new talent to develop something that is not conventional anymore. Here in Brazil, we have WEG, which is a large manufacturer of electrical equipment. You know, motors are not what they used to be, and electrical switching equipment is not what they used to
Yeah.
be. And there's a lot of innovation in those.
Let's go to the second one.
Yeah,
Energy efficiency experts. To be an expert in something must be very, let's see, you need time to
yeah,
have
yeah,
experience enough.
exactly.
How do you
But see,
see
yeah,
options in this?
that word experts doesn't necessarily relate to young students coming out of a university. It may relate to a company that has built its reputation on being able to provide services that provide energy efficiency for its clients. And then those companies will be interested in absorbing new talent that is focused not just on building the same old equipment, building motors, transformers, or whatever, or cars, but students who, even at their university, have had experience in projects, and maybe their master's dissertations or their thesis were focused on innovative things.
Yeah, but the consulting companies, the big ones, I mean, the Deloitte,
Yes.
McKinsey, they
Yeah.
probably are receiving people, experienced people to be energy efficiency.
But not just there. It's a pyramid. The bottom of the pyramid is wide, and the bottom of the pyramid is still being built because they recognize that for many areas in which they have clients, for example, staid conventional companies, but they have a demand for energy efficiency, which is a part of a large company. New talent will provide support for maybe more experienced people. Some of their professors might be consultants for those companies. The students may end up working together with their old professors. But that is a realistic way that things work, because when you're talking new developments, an energy transition that goes from what we used to have 10, 20 years ago into a new grid. We used to have point sources. Now we may have sources that are all over the place. That's a whole different ballgame.
That's right, and probably artificial intelligence is replacing a part of these experts.
Yes.
No,
I would say artificial intelligence is being used to develop some of these things. So the new talent has to be conversant with the methods that employ artificial intelligence. There is no reason or room to fear that artificial intelligence will take away the opportunities of new talent, of new professions. On the contrary, the new professions will have to work with artificial intelligence, machine learning, large data processing to devise the solutions. So in all of these cases, they have to be conversant with new technologies and capabilities so that they can bring new solutions even to existing companies, certainly large consulting companies, but also existing manufacturing companies. They won't exist unless they modernize.
Yeah. Let's talk a little bit about electric vehicles, EVs. And that in Brazil, we are importing every electrical vehicle that we use here. And the United States are increasing imports from China, BYD.
I think this is a case where it's regional. Certainly, there's no doubt that China will be the leader for a long time. Quite a while back, myself and another professor who is now deceased wrote a very interesting article on where electric vehicles, especially the self-driving ones, will be. And we propose that Tesla will be the initial leader, and then Google with its cars, and then eventually Apple. It hasn't happened yet, but I think we're on the path because this is a long-term game. It's not a 5-year thing. It's not a 10-year thing. The electric vehicles are growing very fast, but from a very small base. That we understand. So it's insignificant what we will have 5 years. Maybe 10 will be a big difference. But it's a slow process because we're starting from a very small base. Sure, China is way ahead. So we will need people who will be conversant with electric vehicle technologies, all the way from batteries to new transmission systems, new powertrains, and so on. But remember, electric vehicles is not the profession of the future everywhere. And in particular, I think I said this in another program, I don't think in Brazil or in many other countries that have a vocation for biofuels that they will be as big a player in the automotive market as they might be in other countries.
I'm not sure that you said, you saw today the fight between Tesla and Apple.
Yeah.
Tesla saying that we'll remove
No,
Apple
no,
computers from his
no
factory.
Apple equipment. That's exactly what I'm saying. We saw the writing on the wall a while back, and we saw that over, 5, 10, 15 years, a lot of things change. And we're in the first 5 years from having written the article. And in this first 5 years, yes, Tesla, with all of its innovations, is providing, a work environment for a lot of new talent, and that is a good place to be. But after that, the next 5 years will not be Tesla's, will be other companies. Unfortunately for Tesla, but I mean that's our
Yeah.
view, and it still will demand people. Those people will work
Yeah.
somewhere. They may not work at Tesla, but they will find work.
And what kind of professionals EVs are requiring at this time?
Well, certainly for electric vehicles, we're talking conventional, new powertrains, electric and so on, new transmission modes, because the cars are different weights and so on, everything from brakes, from wheels, chassis, and
Mechanical
certainly,
engineers, of course.
yeah, mechanical engineers and chemical engineers. And we mentioned before, you have to organize these things and you have to uh, take the big view, a wide perspective of the electric vehicle marketplace. And now some of the automotive companies are doing that, because before they were just saying, "Oh, we'll have an electric vehicle model," but that's a point thing. That's not a overall view. That's not strategic. That's just tactical.
Yeah.
And the strategic view is that you have to develop the electric vehicle marketplace with everything from small cars to high value cars, everything from small
And a lot of automation. So people from automation that can be
of
very
course.
special.
And then as you go to self-driving vehicles, you have a lot of data scientists that have to work with large data sets, artificial intelligence,
Communication engineers.
and we've already seen a lot of news about cameras with new systems to recognize people, for example,
Yeah.
50 times faster than other camera systems.
And
That is
in
essential.
Brazil, do we prepare people for these targets in Brazil or not yet?
Maybe we don't prepare, but we allow people with those
Yeah.
skills to be coming out of the system. One advantage is that we have not only universities, we have federal technical institutes that are very important in developing technical
Yeah.
skills for people who might eventually go to universities, but before so, they already have a lot of skills.
But we export talents from outside Brazil because we do not absorb these people here.
That is a problem. For example, we have here in the city in which I am, in Petropolis, we have a very important technology center. We have the LNCC, National Laboratory for Computing and so on. We have world-leading companies in communications technologies, but they are developing their talent in-house. This is what I mentioned. We don't necessarily need the universities to train them. The federal technology institutes, the universities can do fundamental teaching, and then those companies will polish those talents for what they need. That last bit of 1 year even is as valuable as 5 years before.
Going to the last point of this slide, policy analysis, but making a difference between policy and a regulatory analysis is totally different. Please, your comments.
Yeah, I think that a lot of times people look at government jobs as opposed to private industry, and they say, well, if I go to a government job, I'll work with policy and so on. But we have to understand the world is more and more going towards bigger and bigger companies. Nowadays we have several trillion-dollar companies. Those companies cannot afford to just think tactically. They have to think strategically, and they have to develop policies and work with policies. So
policy are not lobbyists.
No. Yeah, those will always be needed. I don't know how artificial intelligence will deal with them, But lobbying for policy is one thing, to get benefits, but to understand the kinds of policy that the company can develop to develop its business.
Yeah.
Sometimes that means working with government policy, because if we have governments that are already set on the energy transition, it's no use saying, "Oh, I don't
Sure.
want energy transition." That's set. Now we have to work with that. And if you're not part of it, you have to develop a policy to become part of that. You have to devise a way to participate. This happened to a lot of oil companies. They were fearful. They said, "Oh, we're going to be antagonized. We're antagonists to the policies of energy transition," and it
And,
doesn't have to
and,
be that way.
and there is a special point in this sector of policy analysis that that's the compliance guidelines.
Yes. ESG is here to stay. Obviously in the United States, there's some states that are ridiculously trying to control that. But that's like trying to control progress and so on.
Yeah.
Obviously, it's not that. Government has its place in regulation, in developing standards and so on,
What,
but not compliance. Yeah.
sorry, what kind of professionals fit to this policy analysts group?
Definitely, the technical, scientific, even economics is very important, because when you talk compliance, you have three aspects. You have regulatory and legal compliance, which someone has to interpret it and orient. You have the technical side, where your company or your product has to meet those requirements. And you have the internal policy side, which is administrative, which is controlling the organization so that it can function in those capacities. No matter how technical you really are, and a lot of people enjoy saying, "Oh, I love math, and I love being an engineer. I don't care for administration or economics." Forget it. You have to have your foot also in administration, understand economic principles.
Okay.
You have to understand how companies operate. They make money. If your company doesn't make money, you're not going to have a job. So you have to understand how they work.
Yeah. Going to the next
Exactly what
slide.
project managers. How do you make a company make money? You don't just produce a product. You have a project to produce a product. You have to have everything from the beginning to the end. Project management nowadays is a lot more than just knowing project management software, which a lot of people are conversant with, and I think is very important. But this applies to all kinds of new projects: renewable energy, alternative energy. If you're a new company, a startup or whatever, you have to have a project to take your innovation or new invention into the market. But if you're a big company, it's the same thing. You don't take a Starship without a project. You have to consider all of the underlying principles that govern the success of a project, and then you start employing many careers. But the project managers themselves are specialists. Yes.
And Cleveland, because parts of the project may be constructed, manufactured outside the country, and you have movements of parts of country.
There are people that are specialists in outsourcing. It's impossible not to outsource something on a big project. There is a trend nowadays, for example, reshoring in the United States, because natural gas is so cheap. You bring in petrochemical industry and so on. That's different. Outsourcing means you have a project, you can't stop to develop, a new gadget. You buy from China or Mexico or whatever, and get your project in as short a timeline as possible.
And more related to engineers and administrators, this item?
Oh, of course. In administration, project management is a specific category that is very important. I have a lot of, I have several students that are mentees in the oil and gas industry, for example, and the electricity industry, that are working in right from the beginning, as soon as they were hired, in project management managing a project for their company or helping to manage a project for their company.
Yeah.
This is not one person. These are teams. And these are such complex projects that require enormous computing power. They're so complex, thousands of lines of items.
Yeah,
And to manage something like that requires expertise.
but more related to international companies, big ones that are
No.
has
Nowadays, come on,
local ones.
a gas to energy project in Amazon requires all of that.
Okay.
Because you have the gas production, you have the generation, you have the electricity production, you
Okay.
have so these things happen in our industry all across company size. Maybe not in storefront, but manufacturing always requires project and the software that is out there. A lot of times you use off-the-shelf software when the company is smaller, but many companies develop their own because they have their own requirements, and you have to be conversant with that type of software to develop something new or work with something new in your company.
Okay. Data analysts, probably data scientists.
Exactly, that's the word. Whether it's the energy sector or something similar. Nowadays, the trend is to use more and more the data that is available. We've always had much more data than we were able to analyze because data can be produced, Internet of Things, a motor can produce, so much data just running, frequency, rotation, heat, whatever, energy, because that wasn't being used. Nowadays, we're learning that is a gold mine. So you have to use that information. And to massage it, you have to be conversant with machine learning, artificial intelligence, large data sets to be able to extract the value from that.
Okay, perfect. Hydrogen. Oh my God, this is my weak point.
I know, especially because I like hydrogen into the future. I'm not arguing it now. So guys, don't dive into hydrogen just because I like it, because that's maybe some years away. But this is an example of things that we know will happen in the future. So you don't study and decide you want to be a hydrogen energy specialist, but when you study the things that you like to study, you have to keep an eye on the fact that hydrogen will become, I'm saying so, will become a major part of your company if it's devoted to energy. So you're not going to lose your job in 20, 25 years, but if you're conversant,
but
do well.
Must be specialists to work in this area, no? Very specialist.
Well, if you want to do something, for example, develop hydrogen as an energy source, look for hydrogen sources, white hydrogen, work, as you know, one of my hot topics is gold hydrogen, where you inject bugs into spent depleted oil and gas reservoirs, and you end up producing hydrogen. Yes, you have to be very specialized because it's a new field. But
Totally new.
In an energy company, when you know that hydrogen will become part of its energy mix, you have to just begin to understand a little bit more about the whole.
Is more for chemical engineers, this sector?
Not really, because what I see hydrogen developing is not so, well, we know green hydrogen is hot at the moment, but the future, I believe, is not necessarily green hydrogen, but maybe natural hydrogen, white hydrogen, and so on.
Yeah.
And those are more dependent on mechanics, yes, some chemistry, but partly because they will use existing infrastructure of the oil and gas industry, for example. So, the knowledge that you need is, if you're a good oil and gas engineer, you probably will be able to handle the transition to hydrogen.
Yeah. Regulatory, we just...
we discussed that. Yes. I mean, if you're good, you'll go there. But I
let's
wanted to bring this up.
Let's go to the oil and gas sector.
Yes, when we talk energy transition.
Yeah, but see the comment from Luis, forget explore oil and gas in Amazon. I do not agree with him. Sorry.
Okay, well, Cavagna, I personally also don't think we need to go to the Amazon at all. There's plenty of other areas with oil and gas that are
Okay.
more better business to explore for oil and gas elsewhere. But the oil and gas sector itself is going to be with us for 20, 30 years. It's not going to go away just because we like renewables. It's a reality, and we have to be
No,
realistic.
okay, yeah, okay.
So,
But
so
for the oil and gas sector, you
yeah.
mean more related to exploratory blocks and things like that,
Well,
geophysical?
because we're talking a long period, 30 years or something like that at least, we're going to need explorationists because many new areas have yet to be explored, then developed, and then produced. We can't just stop exploration now and just use up everything we have. We have to continue exploration to some extent, maybe with new tools, which is one of the things you mentioned at the beginning. I'm devoted to new geophysical exploration tools, which are less invasive and so on. They will become part of the new geophysics curriculum. And explorationists will have to learn to deal with that because right now, seismic is king. 98, 99% of any exploration budget at the early stage is seismic,
Yeah.
but that will change. And the people who are devoted to understanding geophysics more than just understanding seismic will be able to participate in
Yeah,
advance. And obviously, even in
4D
seismic,
models, for instance.
yeah, even in seismic, we're advancing all the time, new interpretation. Even mechanical engineers in developing sound equipment that is less invasive for whales.
Reservoir monitoring for with 4D is an example of this explanation
Exactly.
you are bringing.
Nowadays, Petrobras, for example, has 4D seismic in many fields, which is monitoring, and this is going to go on for many years because those fields will continue
So a
producing.
strong tool, it's a very special tool,
Yeah.
and for production engineers and
Because we
scientists.
will be producing oil and gas, we have to produce it smartly, less impactful, and so on.
And for a long time, because there is no replacement for oil at this time.
Exactly. But it will change because the old ways will have to change. Not only to be cleaner, environmentally less harmful, residues of the production process, injection water treatment, all of those things will change, and you have to keep up with those changes because that is what is going to be required for that production to take place.
Yeah.
It's not production like we had 5-10 years ago. It will be very strictly controlled. It will be less impactful, and it will be very productive.
And with a gas reinjection, CCS, carbon reinjection, how do you
Same
see this?
thing. A lot of the oil and gas industry will become repurposed. It will shift, especially in aging fields and so on, rather than just being decommissioned. Some of it will be repurposed, and those people that can handle that repurposing will be very important because all of a sudden, instead of becoming an asset that becomes dead and gone, a company can get something extra out of it.
What type of professionals can work with CCS and gas?
The same professionals involved in oil and gas production, because basically you have to learn some new skills in chemistry and so on, but certainly in physics, because how the different compounds behave. Obviously, hydrogen, methane, CO2 behave differently than oil and gas. But if you pivot to learning about that, you can become a specialist in that direction. And that is something that we know will happen in the next 5-10 years. More and more companies will have more and more of their business changing so that they will be able to continue producing, but under a much different environment, a much better environment, luckily.
Yeah. The commissioning is more related to environmental, technical people, and of course mechanical, very strong mechanical cuts of this.
But also other areas, oceanographers and so on. This rigs to reefs the trend that we had a while back. Then it slowed down because obviously you can't do things just because you have an idea and then you go around
Yeah.
throwing everything in the ocean and say this is a reef. No, that's not necessarily good. Just like reforestation is very good, but you can't just plant trees somewhere and think that's going to work.
The,
It has
the,
to be
mi-
done with a system.
the Minister Marina Silva will love this speech of you.
Well, exactly. But decommissioning is very important because, in fact, if you were able to provide a decommissioning proposal to a company that can save them money, that can be environmentally actually beneficial, not just less impactful, and everybody can benefit. That's a win-win situation, and certainly if you're a hero, you get money for that.
So you mean that the commission is not cost?
The decommissioning can actually provide benefits. Rigs to reefs is somewhere close to that, but in reutilizing some facilities in the North Sea, for example, we already have several rigs that are repurposed as hotels and entertainment areas and so on. Obviously, that can't happen to all of the rigs, but these are new ideas, and people have to think in new directions.
Yeah, but we spend money to make this.
Yes, but that's an investment that can pay off handsomely
Okay.
in the decommissioning phase. And I do want to say that rigs to reefs is there and other benefits, fisheries and so on. So oceanographers, environmental scientists do have a place in that, because the decommissioning, the whole purpose is to be able to take care of a liability or something so that it doesn't become a liability. And maybe you can even turn it into an asset.
And finally, what type of professionals are for geopolitics and economic or international relations?
Obviously there is a skill. People study international relations, and they study business strategy, economics, and business management, and so on. And that all involves geopolitics. But we have to recognize that energy nowadays is a tool of geopolitics. So obviously, geopolitics is the driving mechanism. And we have to understand how Russia, how China, how the US, how Western Europe has been part of this. Either they suffer the consequences, or they are the leading promoters. And this is very important to understand. But the skills can be learned in parallel to all of the technical and scientific skills. You just probably won't develop new talent into a high level position, because those are mostly tied to C-level levels at the companies, executive levels.
The conclusion could be that we need all type of professionals in the energy sector, but what are the most required professionals in this sector?
The basic sciences have to be there, because the basic sciences are what lead to innovation, and innovation is the key. So even if you like electrical engineering or anything else, you have to have the best possible education in basic sciences, mathematics, chemistry, physics. Then you can pivot into anything you come.
Okay.
It's the future.
Perfect. Thank you so much, Professor Cleveland Jones.
It was a pleasure.
A great pleasure.
I hope a lot of new talent will find enthusiasm here, because a lot of times I've discussed with people who were disheartened. There is no reason to be disheartened.
And we can come with students probably to discuss a little bit more their anxious processes, what they are thinking about these opportunities. And so thank you. Have a great day.
Okay. Take care. Bye-bye.
Thank you. Bye-bye.